Hello everyone, let's solve GATE paper CS1 question 47. Consider a relational schema team with name, city, and owner with a functional dependency as name on city when name on owner. The relation team is decomposed into two terms, T1 and T2, where T1 has name and city versus T2 has name and owner. Which one of the following statement is true? Multiple answer question. Let's understand the prerequisites. Let's first understand what is a relational schema. So, a relational schema is a stable structure in our relational database. For example, as mentioned here in the question, team of has name, city, and owner. This schema has following functional dependencies. Which functional dependencies? Let's write. So name on city, owner. Together, they imply that name implying city, comma, owner. Okay. So name uniquely determines both city and owner. This is what we can figure out. What is a functional dependency? A functional dependency A towards B means if any two tuples or basically rows have same value of A, then they must have same value of B. In our case, if two teams have same name, अगर teams के नाम same है, then they must have same city and the same owner. Okay. This is from the question we are figuring out. Till now, we are only discussing. So let's understand the type of keys used here. Candidate key. It is a minimal set of attributes that functionally determines all attributes in a relation. So minimal set of attributes. So this you can see from functional dependency name towards implying towards city and owner. Here, name determines everything. Name can determine everything. Name is a candidate. It is a minimal set of attributes that functionally determines. Okay, that is something very good. It can functionally determine all the possible attributes. Let's talk about voice chord normal form, because if you read the question, BCNF is mentioned. A relation in BCNF, a relation R, is in BCNF, is in BCNF, which is voice chord normal form, if for every non-trivial functional dependency, for every non-trivial functional dependency, FD, X implying Y, X is the super key. Let's test. So if I start testing this relation R and BCNF, so name implying to city, name implying to owner are functional dependencies. Okay. So name is a candidate key. We already figured out. Candidate key, that means it is a super key. So we can say this relation is a BCNF. Okay. Again, I'm saying what is a BCNF relation? A relation R is in BCNF if uh, X is a super key in a non-trivial functional dependency when X is implying towards Y. So here our name, you can see. Okay. But wait, this much we figure out. Only if these are only FDs. Let's see the exact question again. This relation is in BCNF only if These are the only functional dependency. Let's see the exact question again. Third normal form. Let's talk about third normal form a bit. A relation is in third normal form if for every functional dependency, x implying to a, at least one of this holds. What needs to be whole? A is a prime attribute. What is a prime attribute basically? So prime attribute is a part of candidate and x is a super key. Since name is a super key in both of them, and A is one of the prime attributes or like part of the candidate key because one of we are able to figure out. So team is in 3 and F. I can say uh, team basically is in 3 and F. Okay. So lossless joint decomposition. We are only talking about the optional, like what are options given to us, na? So whatever concepts we need to know, we are talking about them. A decomposition of R into R1 and R2 is lossless. A relation R is decomposed into relation R1 and relation R2, and that is lossless if common attributes of R1 and R2 forms a key in at least one of the relations. The common attributes should form a key in at least one of the relations. Let's see. So team, name, city, owner, implying T1 of name comma city and T2 of name comma owner. So the common attribute is name. Since the common attribute is name, name is present. His name is a key in both decomposed relation because it determines all attributes in them. This is a lossless join. Okay, let's talk about preservation of functional dependency. Uh, since we have talked about all this, even though it is not mentioned, let's still discuss a bit. It will complete the whole thing. All original functional dependency can be inferred from decomposed relation, as you guys know. So T1 and T2, uh, T1 has name and city, and T2 has name towards implying towards owner. All original functional dependencies can be inferred from decomposed relation. So the dependency preservation is also satisfied. Okay. Now, once this is done, let's talk about the given options. So the given options were schema is given, and it is decomposed into T1 and T2. It is already preserved, as you can see. Preservation of functional dependency is going on. Option A, relation is not a BCNF. We just proved that since name is a candidate key and determines all other attributes, and all other functional dependencies have name as a LHS, it is in BCNF. Okay. Relation T1 and T2 are in BCNF exactly because name implying towards city and name is a key, else BCNF. Name implying towards owner and name is a key, so BCNF. The decomposition constitutes a lossless join. True. Common attribute name is a key in both decomposed relational join. Okay. Uh, relation is not in 3NF. False. Since name is a super key, all the functional dependencies have LHS satisfying 3NF. Okay. So option A was like relation is not in BSNF. It is actually in BSNF. So option A is wrong. Option D is wrong. Option B is correct. Option C is correct. So the final answer will be option B and option C. That's it for this particular video. Take care. Bye bye. See you guys in the next video.